Hello guys, in this video we'll understand the k nearest neighbor algorithm and a example problem. The algorithm is inputs. What are the inputs you're giving? There is training data set T, distance metric D, test instance T, and the number of k nearest neighbors K. The output is predicted class or the category, the prediction. Here are the steps. For the test instance T, for any particular instance T, for each instance I in T is a training data set, compute the distance between the test instance T and every other instance I in the training data set using a distance metric, that is Euclidean distance formula. This is the formula. You have to use this formula to calculate the Euclidean distance. Then the step 2 is sort the distances in an ascending order and select the first k nearest training data instances to the test instance. The third step is predict the class of the test instance by majority voting or mean of the k selected nearest instances. These are the steps you need to follow to solve the problem using k nearest neighbor algorithm. Let's have a look at the problem. Consider the student performance training dataset of 8 instances shown in the table, which describes the performance of individual students in a course and their CGPA obtained in the previous semesters. The independent attributes are CGPA, assessment, and project. The target variable is result, which is the discrete value variable that takes two values, pass or fail. Based on the performance of the student, classify whether the student will pass or fail in the course. This is the training data set table. Next, coming to the solution, the test instance, this thing will be given in the question itself. We have to assign k is equals to 3. Step 1, we need to calculate the Euclidean distance for each of the instance. So first instance here is CGPA 9.2. So that is only you're taking. And then assessment value 85, project submitted 8. This is the table values that are being given in the question. And the result is pass. Now you have to apply the Euclidean distance formula and add all the values. The CGPA, the formula Euclidean distance formula is for the points x1 comma y1 comma x2 comma y2. For this point, the formula will be like this: x2 minus x1 whole square plus y2 minus y1 whole square under a square root. So you need to apply the same formula here. Here x2 will become the CGPA value of the instance which is given, and that 9.2, and the x1 value will become the test instance, that is 6.1 my whole square plus y2 is 85, test instance is 40, 85 minus 40 whole square, 8 minus 5 whole square, put it under the square root, calculate. You will get the Euclidean distance value. Similarly, you have to do for all of the instances in the uh, training data set. Once you get all of the Euclidean distance value, the second step is to sort the distance in the ascending order and select the first three nearest training data instances to the test instance. So the when you calculate this, you have to arrange it in the ascending order. See, you find the least value, that is 5.001 is the least, no, 2.0022 is the least Euclidean distance, so that is there here, and then 5 is also there, and the other one is 10.57 something. So these three are the least uh, Euclideans. These three are the instances with the least Euclidean distance. Then also make a table with the instance number, the Euclidean distance value, and the class. All these classes are failed. See, for the 10.05 Euclidean distance, the result is fail, 5 fail, and 2 fail. So this is the step 2. Here we take the three nearest neighbors at instances 4, 5, and 7 with the smallest Euclidean distance. Now the third step is to predict the class of the test instance by majority voting. As you can see, all of these classes vote, the result is fail. So hence, for the test instance, 6.1 CGPA value, assessment is 40, and the project submitted is 5, will be failed. the result of this test instance will be failed. You can tell this, you can come to this conclusion by applying the k nearest neighbor algorithm, by finding the Euclidean distance, sorting it into the ascending order, and then by comparing the result value according to the majority voting. So we can conclude that the class for the test instance is predicted as fail. This is as simple as it is. You can do it very easily in the exam. Thank you.